Good day, class. Let's talk about exponents. Just to simplify, are we all good with the number 2? We know how to multiply by 2, play around with the number 2. 2 is an easy number. Let's go with it. So, in this little box here that we got, and all of these, let's focus on the bottom one. So, what does this actually equal to? I'm going to say 2 times 2 is just going to be 2. 2 times 2 is going to be 4. 2 times 2 times 2 is going to be 8. 2 times 2 times 2 times 2 is going to be 16. 2 times 2 times 2 times 2 times 2 is going to be, brain slip, 32. Okay? So from there, we can just figure out the exponents by just counting the number of 2's. So over here we had 2, and there was only one 2. Over here we had 2, and there were 2 2's. Over here we have 2. How many 2's? 3 2's. Over here, how many 2's do we have? 4 2's. Over here we have 5 2's. We will get back to these squares over here. But for now, we understand how this counting game works, what exponents work as. It is a bunch of multiplication. As a quick summary and review of things that we knew already, when you're younger and you learn how to add, you're a baby level, that's level 1, addition. Eventually, you learn that, well, if I'm going to add a bunch of things, it's just easier to go call it multiplication. So say 3 times 5 is the same as 3 plus 3 plus 3 plus 3 plus 3. Cool, but I can just write it as 3 times 5 and give me 15. Multiplication is a bunch of additions. This is why it's a level 2. Now you're getting older. Nana is the grandma of Bluey, so just going levels by levels. If I have 3 to the 5th power, that is 3 times 3 times 3 times 3 times 3. So it's exponents are a bunch of multiplication. In level 2, multiplication is a bunch of addition. Level 3, exponents are a bunch of multiplications. Hopefully there's a pattern that you see in recognition tests, because we will be using that as we progress. On the flip side, subtraction, the opposite of multiplication is subtraction. The opposite of opposite addition is multiplication. Is subtraction. Opposite of multiplication is division. Subtraction is the level 1. Level 2 is division. You want level 3, you gotta wait till Algebra 2. We might talk about that. Okay, terms that Mr. Dang likes to use when we're talking about exponents is the big world versus the little world. The big world is just the everything writing outside the stuff with the big numbers, the bases. And the little world is what's focused inside the exponents. So hopefully that makes sense. That's why I wrote this out as big versus the little above on the exponents. So let's just practice some of our multiplications. If we're familiar with our multiplication good enough, 2 times 4 is just 2 plus 2 plus 2 plus 2. And then if I said 2 times 3, that's also just 2 plus 2 plus 2. That's very straightforward. You should be well aware of this. This is elementary things. You're a smarter class now. You got this. But if I were to combine that and say, hey, what is 2 times 4 plus 2 times 3? I can just take what I had written earlier, plug it on this side, take what I have over here, plug it over here. So I get this 2 plus 2 plus 2 plus 2 plus 2 plus 2, which if I just count up all my 2's, 1, 2, 3, 4, 5, 6, 7, that is 2 times 7, which is 14. That's pretty straightforward, right? That's how we do addition. Let's level up. So leveling up, we're doing exponents now. We were just talking multiplication. That's the mama level. We're talking grandma level now. Level up. 3 cubed, 3 to the 3rd power, is 3 times 3 times 3. 3 to the 4th power is 3 times 3 times 3 times 3. So if I'm going to ask you 3 to the 3rd power times 3 to the 4th power, then that's going to be a lot of 3's here. Pay attention. 3 times 3 times 3 times 3 times 3 times 3 times 3, which if I just count them all up, 1, 2, 3, 4, 5, 6, 7, I get 7. This is some sophisticated work here, but I started off with 3. And then I did something with 4. Then I got to 7. What is this? What would the magic operator be in between these two? What do you think? It's addition. In the big world, when we were multiplying, right here. But in the little world, it becomes addition. Because when we bring it out, only looking at the exponents, we just added them together. This works when the bases are the same. Right here, I had the base 3, the base 3. So I can, you try. Base 5, base 5. What do you do with this one? Give you a few seconds to figure this one out. You can pause the video if you need to, but I'm assuming you can figure this out on your own. Go. This is a 5, and then you have, because we're multiplying, that means in the big world we multiply, in the small world we're going to add, which is the same as 5 to the 5th. For right now, I'm just going to ask you to leave it in exponent form. You don't have to solve out on what this actually equals to one number. Bases are the same, so I have 4, 5. Since it was multiplied in the big world, in the little world, it's an addition, which then gives you 4 to the 12th. This also applies not just to numbers, it also works with letters as well. So as long as the bases are the same, A, so I have A, 4th, since it's multiplying, I can just add these two together, 9, I'm going to get A to the 13th. There's a secret 1 here, because if a base has no explicit exponent, it just means it's to the 1 power. So this is going to be C, 3 plus 1, which is C to the 4th. Ooh, here's something tricky. Add the bases together. So I have the A's first. A, that's going to be 2 plus 8. And then I have B, which is 3 plus 5, which then just equals to be A to the 10th power and B to the 8th power. Division or fractions. When I have fractions, I love canceling. Do you love canceling? I hope you love canceling, because this is going to be a fun way of treating. When I see an equation like this, if I had written this as a number, that would be a whole different thing. But if I can break it down to their prime factorials and be like, cancel this, 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 cancel this. That's so satisfying. I'm left with just this. That's just equal to 2. Ooh, more complex. 4 cancels, 5 cancels, 6 cancels, 7 cancels, 8 cancels. I'm left with 9. That's nice. I like that. If I had something like 3 to the 3rd power, 3 to the 3rd power times 5 to the 3rd power over 3 to the squared times 5 squared. Well, let's see what I can cancel. I can cancel these 3's. I can cancel these 5's. And then I'm left with just a 3 and a 5. 3 times 5, which is also 15. All right, you do. What can we cancel? You have this beautiful number, broke it down into this set. Play the canceling game. Knock them off. I'm assuming you don't need to pause because you're quicker than me, but I'm gonna catch up. Cancel, 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 cancel. All right, that's left. All left. I'm gonna circle what I got left down here, and these ones up here. So I have 2 times 7 times 7 over 11 times 11, which is, I can put in exponential form as 2 times 7 squared, because there's still 2 7s, and 11 squared. I would be okay with you leaving it in this form. If you're actually going to do the math out, it's not the hardest. 7 squared is 49. 49 times 2 is 98. 11 squared is 121. Either answer is going to be okay in my opinion. So with fractions are just division. So what can we say about division and exponents? Big world, little world. Big world. Let me go back. If bases are the same, big world, division results in little world. What's the operation that took place here? Because we started with 2 squared on the top and 1, 2 on the bottom. In the end, afterwards, we have 1, 2 at the top. 11 to the 3rd power, and on the bottom we had 11 to the 5th power. So in the end, we had 11 squared, 2. We had 7 to the 4th, and then 7 squared. And then at the top, we were left with 7 squared. The pattern, if you're going to write out the numbers that we saw, was 2, 1 equals 1. 3, 5 equals 2. I'm going to put absolute values around these things. That's kind of how we actually did it. And 4, 2 equals 2. We ended up minusing everything. Since we kept this still on the bottom, it still stays with a positive. So it's small world minus, or subtract. I like the word subtract more. Subtract. You do this next one. I'll leave it to you. Take your time. Cancel things out. Minus them out. Do one number at a time. I would recommend leaving the denominators. I like things positive, so if it's going to be positive on the denominator, keep it on the denominator. Here we go. So I have more 5s on the bottom because it's 5 to the 7th versus 5 to the 4th on the top. So I know that the 5 is going to be on the bottom. There's going to be 3 of them left. 6 is more on the top, so 6 to the 6th power. So 6 minus 1 is 5 on the top. There's more 9, so it's going to be 9. 3 minus 2 is 1. This is a fine answer. I don't want to know what the actual number is going to be. 3 to the 2, 13 to the 3rd power, times 8 to the 4th power. Yeah, you can leave it that way. I might clean this up a little bit. There we go. Make sure you understand it's a 3 to the 3rd power, not 133. All right. My favorite exponent is 0 because anything to the 0 power is 1. Easy peasy, lemon squeezy. Set, done. I'm going to give you 4 seconds to do the next problem, so you probably only need 3. Ready, set, go. 1, 2, 3, 4. It's 1. This is 1. This is 1. This giant big number to the 0 power is 1. This is my favorite exponent. It's a good reference check. Okay, negative exponents, or what Mr. Dang likes to call flippy-floppy. Smart people use the word reciprocal. Reciprocal is a very respectable word. It is when you switch the denominator and the numerator. Generally speaking, you can always remember that a whole number also can be written as whatever that is over 1. So 5 here is 5 over 1. And if you take the reciprocal and you flip it, you get 1 over 5. That's the smart way to do it. The reciprocal of 5 is 1/5. I like the word flippy-floppy. The flippy-floppy of 7 is 1/7. Means the same thing. Means the same. This might be an SAT word later in the future. This will not. You want to be smart, so you can use the better word. It helps me to remember what this actually does. So reciprocal is a flippy floppy. To harp at the point, something to the negative power is going to be 1 over something. So we know that the negative exponent flops it. The negative exponent is the key here. That negative 1 power flips things. Just to make a point, anything to the negative, let's say negative 6, is going to be 1 over anything to the 6th power. That 6 still plays a role. It's just that negative flips it first. We understand that? Negative power flips it. Flippy floppies. So going from that logic, 5 to the 3rd power is going to give you 1 over 5 to the 3rd cubed. 5 cubed, we already know is 125, so it's 1 over 125. Flippy floppy. 1/6 to the negative 2 power, that flippy floppies at flippy backs. A lot of flippy and floppies. All right, just bear with it. So we already have something that's in a fraction, but because we have a negative exponent, it flips it back. That leads us to 6 squared, which is 36. Flippy floppy. Use the word reciprocal in class. I'm sure it'll make you sound smarter. But for you to remember things, flippy floppy it. This is the difference from outside voice and inside voice. Mr. Dang has a lot of voices in his head. You do. Go. I have faith in you. You can solve these. You can pause the video if you need to. Otherwise, this is going to be 3. Now that I got flippy floppied, it's going to be 1/3, and then 3, which is also 1/27. To the 4th, this is a 1/2. So I flippy floppy it. That gives me a 2 to the 4th, which is the same as 16. This is you're going to flippy flop both parts of this. So we're going to have 4 over 2 now to the 2 power, which is also going to be 16 on the top, and then on the bottom it's going to be 4, which you can break down to just be 4. That just divides into 4. Sometimes this applies to a specific number. This is being flippy. The 3 is being flippy flopped to the 2nd power times 5, and so we have a fraction that is 5 still stays on the top. 3 goes down, which is 5 divided by 9. We have 3 cubed over 4 to the negative 2 power times 5. Well, that 4 is going to get flippy flopped and bring back onto the top. That's going to give you a number. Oh, I made a mistake here. Typo. This should be 16. Off the top of my head, what does 70, 27, oh, I have to do this. Sorry, 42, 6, 12, 16, 0, 7, 2, 3, 4. So this should be 432 over 5. My bad. Even Mr. Dang makes mistakes. Silly ones even, specifically. Yeah. Alright, you do this next one. What gets flippy floppied, where it goes. Pause the video if you need to. Else, gonna go. So this is 2 over 1 to the 3rd, and times 6 on the top. I guess you can write it this way, which is the same as 6 over 27. Oh, not 27. Ooh, what am I talking about? Over 8. 7 goes to the bottom, and 2 stays up on the top. I can lie, that's okay, a little better. Which, if I was to simplify that, this gets 49. On the top, we're gonna get 16. Because 2 times 2 times 2 times 2 is 16. For me, I just like to simplify, make sure I don't like negative exponents, so I just take all my negative exponents and do the flippy floppy as I need to beforehand. So I have on the top, this is gonna go bottom. This is gonna go to the bottom. This is gonna go to the top. My 4 still stays there, and my 6 still stays there. So if I were to divide this, I have 9 times 4, and over here I have 8 times 6, which is 48 on the bottom, and 36, which I'm sure I could have reduced down beforehand by 4. That's 12 over 9. Oh, I can reduce that down too. Ooh. Which is equal to 3 over 4. No, okay, that's actually... power over a power. So, in the big world, we were talking about 2 squared to the third power. 2 squared cubed. That 3, the cube part, is in the big world. In the small world of the exponent, it would just make it multiply. So when this thing, in the big world, exponents. In the small world, when this happens, that means when you translate it through, it becomes a multiplication. That becomes 2 to the 2 power times 3, which is just 6. So 2 to the 6, which is 64. So this when this goes out, it becomes a minus 3 to the 6 power. And you can leave that like that for now. This one is x to the 2 to the times 5 power, which is the same as x to the 10th power. Y to the, what is 6 times 4? 24. Exponents distributes over multiplication and division. Do you remember that multiplication distributes over addition and subtraction? The way we write this one out is 2 distributes to these two, which gives you 2x and 14. Yes, you remember? Great. Exponents does something very similar when it comes to multiplication. If the stuff on the big world being multiplied and you have an exponent, you can distribute that out to all of the little parts. Why? That becomes 4 squared and 5 squared. Over here, it also does it to divisions. So the 3 that is being the exponent applies to the base 3 and to the base 6. And that's why you have 3 cubed and 6 cubed. You try that. Distribute. Pause if you need to. Otherwise, you have a head start. Go. Distribute. 3 to the 4th times 2 to the 4th. I'm gonna leave it there, even though this does equal 81 times 16. Don't want to actually do that math off the top of my head. Fine. 81, 16, 6, 48, 1, 8, 6, 9, 12. There you go. This distributes, so you have 2. When you distribute that becomes an exponent onto an exponent. If the big world is exponent on exponent, In the little world, it is exponent times exponent. So that is 2 times 3 times 5 to the third, which is the same as 2 to the 6 times 5 thirds. I'm okay with you leaving it like this for now, because I want you to see exponent form. Distribute, and we have 4 to the 4th power and 7 to the squared. I'm trying to think 16 times 16. Don't know what 16 times 16 off the top of my head, and so I'm not expecting you to know it. The bottom number I know, 7 squared, is 49. But we can keep it like this for now. This applies generally too, so even to letters, it will still work. A to the C times B to the C. This distributes, the Z distributes to the X and the Y. So arcs Z over Y Z. This distributes to all 3 points that's in here. So X A C times Y C over Z B C. Do exponents distribute over addition or subtraction? If I had something like this, x minus 2 squared, can I distribute it out? No, can't do that. All this, nope. All this really does is lead it to be x minus 2 times x minus 2, because it's 2 of them. There's 2 of them. There's 2 of them. That's what the exponent squared means. Do you know how to solve this? It's FOIL. Does anyone remember FOIL? Don't worry about it. If you don't worry about it. Don't worry about it until later. There you go. That's a review of exponents. Everything you need to. You have a worksheet. Please do the worksheet.